Hello and welcome everybody to another episode of What's Up with the Universe. Hey, I'm your host Eli Hugh Who, and I want to thank everybody for tuning in today. Whether you're subscribing, whether you're new to the channel, hey, this is what we do. We talk about astronomy. Yes. Last week we talked about our own moon, and we are on the tour of the moons of the solar system. Yes. We are actually going to be talking about today Saturn's moons. Yes, the many moons of Saturn. I mean, one of the major planets in the solar system. Saturn has about 80 or so moons. About 53 of them are confirmed and named, and about another 29 or so are just awaiting confirmation of discovery, official discovery, and official naming. Saturn is mostly popular for its four visible moons. Kelso, Prometheus, Dion, and of course Titan. Of course, there are also hundreds of these little moonlets, as you may call them. Galileo, he first observed Saturn through his telescope in July of 1610. He already announced the discovery of many moons of Jupiter, but Saturn, the furthest planet then known, and twice as far away from Jupiter, was just very more mysterious and very difficult to understand at the time. I mean, Galileo was surprised. He thought Saturn wasn't just one planet, but three. I mean, a big middle planet he saw with a smaller planet and a moon on each side. And of course, they're almost touching. This is what he basically drew when he saw. Galileo described the appearance as a planet with handles. On March 25th, 1655, Christian Huygens. The first moon discovered was Titan, which, of course, was discovered by Huygens. It's the only known moon confirmed to have an atmosphere. Yeah, I know. That's pretty cool. I mean, hey, Corin, we talked about this.
Hey, what's happening? This is Corin Nemic. I'm talking to you from my backyard. Just signed up for Cameo app. Sean asked and told me that's what all the cool kids are doing. Trying to be one of the cool kids. But I am dedicated to this. Dedicated to leaving you a message, no matter what the conditions are. That's why I'm doing this in the rain, to prove to you how serious I am about this. I mean, I will give you a shout out from a train. I'll give a shout out to you while I'm on a plane. I'll give a shout out to you from a car. I'll give a shout out to you from a dive bar. In fact, I heard that David Faustino's on here as well. He said that he was going to give some weird and creepy shout-outs, but I challenge him. You want a weird and creepy shout-out? Came to the right place, buddy.
Get out of here, Corin. Jeez, man. Here I am, just not even 5 minutes into this show, and Corin never wants to interrupt the show with a little cameo. Look, you guys must just get a cameo from Corin Nemic, okay? Maybe he'll stop interrupting my show. Jeez. Okay, where were we? Oh, yeah. We're just talking about Titan here. All right, Titan. It was discovered, Titan, yeah. It was discovered by French astrologer Giovanni Cassini in 1684. Another moon is called Prometheus, which is named after a powerful deity in Greek mythology. Stuart Collins discovered in sometime in about, where was it? 1980, I believe. It was 1980. I don't have it on my notes. Sorry. There's another moon, of course, Dion right here. Another moon is called Kelso, which was named after a Greek mythological character. I know this in April of 1980, astronomer John Fountain, Stephen Larson, and Harold Restima and Bradford Smith discovered this moon, Kelso. Let's see. We also have, of course, this right here. We also have Enceladus. British astronomer William Herschel spotted Enceladus orbiting Saturn around August 28th, 1789. Saturn has, like I said, over 80 moons or so. 53 moons are basically confirmed. Another 29 moons are waiting confirmation of discovery and official naming. Of course, we have Kelso right here, which is photographed by the Cassini, on October 11th, 2005. We also have Enceladus, like I said, was discovered by William Herschel. There is many, many, many moons that Saturn has. So let's name some of them for us, okay? Or how about we name all of them? We have Agarion, Aegir, Albiorix, Anthe, Atlas, Bebnion, Beryllimir, Bestla, Calypso, Daphnis, Dion, Enceladus, Eptimius, and Euripus. Just as a side note, Euripus was discovered on September 23rd, 2000 by Brett Gladman, John Clavers, Jean-Marc Petit, Hans Scholl, Matthew J. Holman, Brian Marsden, Philip Nicholson, and Joseph A. Burns at the Mount Kilauea Observatory in Island, Hawaii. Yes, there's a lot of moons here. Okay, and we also have Barbaruti, Fenir, Forgot, Greep, Haiti, Helene, Hyperion, Hycorin, Leptis, Aeptius, Janus, Jaxana, Carrie, Kibiano, Lodge, Methon, Mythos, Mundafari, Navari, Pacolia, Paline, Pan, Pandora, Phoebe, Polydeuces, Prometheus, Rhea. Yes, those are some of the named moons that Saturn has. Of course, there's also S-2009 S1, this basically new moonlet, situated about 300 miles or 480 kilometers inward from the outer edge of the B ring. This was found by detecting its shadow, which stretched about approximately 25 miles across the entire ring system. And of course, there is Cianarek, Skiarathi, Skull, Skutar, Suttinger, Targera, Tavros, Telso, Tithys, Thymir, Titan, Ymir. Oh my gosh, who came up with these names? Well, if you're wondering who came up with these names, actually, it's the International Astronomical Unit. They basically contribute to all the astronomical bodies. Oh my gosh, that is such a mouthful. I'm going to take a quick little commercial break here. So we're going to be back in just a few moments, okay? Okay, now we are back. Okay, I need that little break. Ooh, that's a lot of moons. Okay, since I didn't name some of the moons for you guys, well, basically, we're going to talk about some of the moons that I named. First of all, we are going to be talking about the moon Titan. Yes, Titan. It is approximately 2 million miles from Saturn, and it's the only one with a sustainable atmosphere. And out of all the planets in our solar system, Titan is the only place besides Earth it's known to have liquids in the form of rivers, lakes, and seas. Yes, there are liquids on the surface of Titan. Of course, Titan is larger than the planet Mercury, and it is the second largest moon in our own solar system. I mean, Ganymede, Jupiter, just a little bit bigger, about 2%. Titan's atmosphere is made mostly of nitrogen, like Earth's, but with just a surface pressure 50% higher than Earth's. Titan does have clouds, rain, rivers, lakes, and sea full of liquid hydrocarbons like methane and ethane. I mean, the largest sea is basically hundreds of feet deep and hundreds of miles wide. Beneath Titan's thick layer of crust, the water ice is more liquid. It's basically an ocean primarily of water rather than methane. Titan's subsurface water could be a place to harbor life as we know it, but while its surface lakes and seas of liquid hydrocarbons can conceivably harbor life, basically it's used different chemistry than we're used to. Basically, life that we don't know what actually it is or how it comes to be, but there are something called extremophiles that we have experienced here and discovered on Earth. I mean, Titan is larger than the planet Mercury. It's the second largest moon in our solar system, like I said. It takes about 15 days and 22 hours to complete a full orbit of Saturn itself. Titan is also tidally locked in a synchronous rotation with Saturn, meaning that, just like Earth's moon, Titan always faces the same side of the planet as it orbits. I mean, it takes about 29 years to orbit the Sun. Saturn takes about 29 years to orbit the Sun. And Saturn's axis rotation is a little tilted like Earth, resulting in seasons, of course. But Saturn's longer year produces more seasons than each lasts more than even 7 Earth years. I know it's a mouthful. Since Titan orbits roughly along Saturn's equilateral plane and Titan's tilt is relative to the Sun, it's about the same as Saturn's. I mean, Titan's seasons are on the same schedule as Saturn's. Seasons basically last more than 7 Earth years, and that year lasts at least 29 Earth years. So that's a long storm. What we have discovered about Titan's internal structure. The internal structure itself isn't entirely known, but one model does suggest, based on data from the Cassini-Huygens mission, that it has basically 5 primary layers. The innermost layer is a core of rock, specifically water-bearing silicate rock. It's about 2,500 miles in diameter. Surrounding the core is a shell of water ice. It's a specific type. What's that mountains? Wait, there's a moon called Prometheus? Is that LG's moon base? Yes, there is. I'm not sure if he actually has it or not, but I'm still talking. We're going to get to Prometheus in a little bit, okay? We're going to get to Prometheus in a little bit. But right now I'm going to tell you guys about the internal structure of Titan. I just told you guys about the innermost layer. But the surrounding core of shell water ice, it's a special type of ice called VI6. That's only found at extremely high pressures. I mean, the high pressure ice is surrounded by a layer of liquid water. It's basically salty, on top of which sits an outer crust of water ice. The surface is coated with organic molecules that haven't rained or otherwise settled out of the atmosphere in the forms of sands and liquids. The surface is a highly dense atmosphere. I mean, Titan's atmosphere, yeah. Titan's atmosphere is mostly nitrogen. Yeah, okay. It's mostly nitrogen, mostly. It's about 5% nitrogen. Easy to say, okay? Just small amounts of other carbon-rich components. High up in Titan's atmosphere, methane and nitrogen molecules, they are split apart by the sun's ultraviolet light and by high-energy particles accelerated in Saturn's magnetic field. These pieces of molecules recombine to form a variety of organic chemicals, basically substances that contain carbon and hydrogen. And they often include nitrogen, oxygen, and of course other elements that basically life-forming elements that are found here on Earth. Some of the components produced by that splitting and the recycling of methane and nitrogen, they create kind of a smog. It's a thick orange-colored haze that makes the moon's surface difficult to view from space. I mean, spacecraft and telescope can't even see through the haze without certain wavelengths that are invisible to the human eye. They can actually see it, but we can't. Some of the heavy, carbon-rich components settle to the moon's surface. These hydrocarbon play the role of quote-unquote sand in Titan's vast dune fields. The methane condenses into clouds that occasionally drench the surface in methane storms. The methane, or methane as you pronounce it, in Titan's atmosphere, it's what makes the complex atmospheric chemistry possible. But where all that methane comes from is still a mystery, because we still do not know the source of it. Yes, I could be doubled as a guy from the planetarium, but the planetarium is closed. Because sunlight continuously breaks down the methane in Titan's atmosphere, some sources must be replenishing it, or it would be depleting over time. Some researchers suspect that methane could be going out to Titan's atmosphere by cryptovolcanism. Basically, volcanoes releasing chilled water instead of molten rock lava. But they're not exactly certain that this or any other possible thing is responsible. I mean, Titan may sound like, in some ways, one of the most hospitable worlds in the solar system. Like, I wouldn't want to go there. It's hell on Earth. Well, it's not Earth, but still. It's Titan's nitrogen atmosphere. It is so dense. How dense is it? Titan's atmosphere is so dense that a human would need a pressure suit to walk around on the surface. I mean, you need oxygen mask, protection against the cold, the radiation. The temperatures on Titan get to a minus 290 degrees Fahrenheit. Yeah, that is freaking cold. That's basically 179 degrees Celsius for all the people who don't use Fahrenheit. Besides the dense atmosphere in Titan, we have a problem with gravity. I mean, the gravity is roughly equivalent to Earth's moon, which basically means that a raindrop falling through Titan's sky would fall more slowly than on Earth. Rain basically falls on Earth about 20 miles per hour, 9.2 meters per second. Scientists have basically concluded that rain on Titan, it falls about 3.5 miles per hour, or about 6 times more slowly than Earth's rain. So basically, you can actually see the raindrop falling about this rate of speed as my finger flows. That's how slow the rainfall will fall. Hope I got that. 1, 2. Yes, I did. About this slow. When there was actually a probe that descended onto Titan's surface, and thanks to NASA, we actually have a little animation of what happened. Check this out. As the 700-pound probe parachuted to the surface, 2 onboard imaging instruments provided by NASA captured views of the moon's cloud-filled atmosphere and dusty terrain. I mean, in a total, about 3,500 images were collected and transmitted to Earth via Cassini. This was a 3.5-hour mission from Cassini. This time-lapse video was assembled from images that were sent back to Earth. That is very funny. Mountains, sure, need mittens and ear warmers if you were with Titan. Yes, but this next planet here is called Enceladus. You would definitely need earmuffs and mittens and a warm jacket, and along with a couple of heavy spacesuits. Yes. Mountains. I love that audio track. I used to have it too. I'm not sure if I still have it on my hard drive. I have to look myself. And Parrot Head, yes, it was a 3-hour tour. I know, a 3-hour tour. But we are now on to the second moon that we're going to be talking about tonight. Enceladus, otherwise known as our ocean moon, discovered in 1789 by William Herschel. For decades, scientists didn't know why Enceladus was so shiny and bright and how it related to the Saturn's E-ring. The Cassini mission, it found that both the fresh coating on the surface and the icy materials in the E-ring originated from the vents connecting to the global subsurface saltwater ocean that might just host hydrothermal vents. The E-ring, it's mainly composed of ice droplets, but of course, among them are particular nanoparticles. Cassini detected these passing silica nanograins, which can only be generated where liquid water and rock interact with temperatures above 90 degrees Celsius or 200 degrees Fahrenheit. At this point, to hydrothermal vents deep beneath Enceladus' icy shell, not unlikely the thermal vents that dot the ocean floor here on Earth, that means that there could be possible extremophiles living down there. Yes, we have found extremophiles on the bottom of our own ocean, so scientists are concluding that the same thing may be happening on Enceladus. The jets I was talking about, it's basically Cassini discovered a lot more information than we actually knew. Some of the key points to know about Enceladus is basically it's a small icy body, but Cassini actually revealed the ocean world is to be one of the solar system's most significantly interesting destinations for future missions. These jets right here, Cassini discovered these geysers-like jets spewing water vapor and ice particles. That's H2O from an underground ocean beneath the icy crust of Enceladus. So that's liquid water on another world besides Earth. Awesome sauce. Before Cassini arrived at the Saturn system, people had a hard time, only basically just hinted that something interesting might be happening on Enceladus. When Voyager passed through in the 80s, it indicated that although this moon is small, it's only about 310 miles across, its icy surface is remarkably smooth in some places and bright white all over. Of course, Enceladus happens to be the most reflective body in our own solar system. Before scientists knew of the plume strength in Saturn's moon, they really were puzzled about the E-ring itself. The E-ring was first observed in 1966, and it's nearly as flat or sharply as defined as Saturn's other rings. The shape is primarily a torus, a faint wispy donut encircling Saturn. The E-ring, it spans from about 75,000 miles to about 26,000 miles above Saturn's equator. Let me give you a little example here. If a highway were paved from the E-ring's outer wisp to the inner boundary and you were to drive nonstop at 100 miles an hour, it would take 2.5 months to get from one end of the highway to the other. That's how far it is. Scientists they built a clear picture of the water ice particles racing through the tiger stripes, as they were affectionately called. These tiger stripes here are cracks in the moon's surfaces. Large particles fall back to surface, but smaller particles travel higher in space. This is what helped form the E-rings. Cassini's basically have a little I can't talk there. Have a little diagram of what they believe what Enceladus actually contains of and what it actually consists of inside. They found the magnitude of the moon to be very slightly wobbly as it orbits Saturn, and it can only be accounted for its outer ice shell is not frozen solid to its interior, meaning that a global ocean must be present because of the wobble. These findings, it implies this little spray of water vapor here, ice particles, and simple organic molecules Cassini has observed, means that this is fed from a vast liquid ocean underneath. Previously, Cassini analyzed that and suggested that the presence of a lens-shaped body of water or sea underlying the moon's south polar region. This is from NASA itself. As you see, the outer layer right here consists of an ice crust, and underneath is a global ocean surrounded by an intense rocky core. The next moon we are going to be talking about is called Iapetus. 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 It's basically one of the strangest moons of Saturn. The density is similar to Rhea, indicating that it has a smaller allotment of rocky materials. The leading side is a dark with a slightest reddish color, while its trailing side is bright. This moon was discovered by Giovanni Cassini on October 25th, 1671. Iapetus orbits at 2,213,000 miles from Saturn. Of course, Saturn has a totally locked Iapetus, which means the moon always gets the same face towards the sun, just like Mercury does. With its inclined orbit, Iapetus is the only large moon from there is a nice view of the rings of Saturn. So if you are standing on Iapetus, you can actually see the rings of Saturn. Iapetus itself, it has a mean radius of 457 miles and a density of 1.2 times that of liquid water, which suggests that Iapetus, like Rhea, is 3/4 ice and 1/4 water. More water in our solar system. Yay. Of course, as you can see here on the image, the dark surface on the right-hand side of the picture, scientists believe it may be composed of matter that was either swept up into space or oozed from the moon's interior when it was forming. We still don't know what caused this dark material, but the dark material might be a thin layer of organic material, perhaps similar to the complex substances found in the most primitive meteorites. However, there are no bright rim craters present on the dark hemisphere. I mean, if this material is thin, it must be constantly renewed since a meteor impact would basically punch the layer and reveal the brighter surface underneath. So this thing must be constantly active with the pull of Saturn, but we still do not know yet. Of course, scientists still speculate that the dark material may have originated from Phoebe, which is very low albedo. I'm sorry, I used the word. Albedo basically means the reflectivity of an object, ratio of reflected light of instant to light. Sorry. I'm trying to use big words. I forgot. Sorry. I apologize. Micrometeor impacts could kick off dark matter off of Phoebe, right here, which is then swept up by Iapetus. Of course, Phoebe has a different, slightly color than that from a dark surface of Iapetus. The fact that the material is on the leading hemisphere seems to support this theory. Of course, on the other hand, the dark material seems to be concentrated in crater floors. This could also indicate an internal origin, like I said, possible internal volcanoes with the stretching of the polar gravitational pull of Saturn. Nemos. Yes, we have our own Death Star here in our solar system. Nemos was discovered on September 17, 1789 by English astronomer William Herschel. Basically, ground-based astronomers could only see Nemos as a little more than a dot until Voyager 1 and 2 imaged it in 1980. Nemos is about 123 mean radius, and it's very heavily covered. It's the smallest and innermost of Saturn's major moons. It's not quite big enough to hold a round shape yet, but somewhat avoid with dimensions of 129 by 122 by 119 miles. I know, it's kind of small. It has such low density that scientists suggest that it consists almost entirely of water ice, which means it's the only substance ever detected on Minos. Basically, at a distance of 115,000 miles from the massive planet, Minos takes about 22 hours and 36 minutes to complete one orbit, unlike Phoebe on Friends, who takes about 3 years to complete one song. Smelly cats. Can you finish that song, please, Phoebe? Smelly cats. Sorry. I made that come because of this. Minos happens to be another moon that's tidally locked. It keeps the same face of the sun. Towards Saturn. I'm thinking about our Mercury for a second. It keeps the same face towards Saturn as it goes around the planet itself. Most of the impact surfaces on Minos our impact craters, they range from about 25 miles in diameter, which is about 40 kilometers. Like that comment, dude. Like I said, the most distinguishing feature of Minos is the Death Star, because it looks like the Death Star, the Herschel crater. The Herschel crater, this little round thing right here, it's about 80 miles across or 130 kilometers. It's about 1/3 of the diameter of the moon itself, with outer walls about 3 miles high and a central peak of 3.5 miles high. Scientists say that the impact that blasted this crater out of Minos probably came close to breaking the moon apart. Yeah, shock waves from the Herschel impact may have caused the fractures, also called chasmata, on the opposite side of Minos. Another one. Wait, LZ just picked Minos. His first team there. Yeah, I agree. He should have picked up Minos. That's a good one. Daphnis, another one of the Saturn's moons. It's called the Wave Maker Moon. This picture here was taken by Cassini spacecraft when it's made one of its ring grazing passes over the outer edges of Saturn's rings on 2017. This is the very closest view of the smallest moon ever obtained. I had to get this picture. I could have got the Keck telescope, picture, but I like this one better, so you guys can actually see it easier. This moon here was discovered by the Cassini mission team on May 1st, 2005. Scientists, before this discovery, they posted that the existence of the moon in Daphnis position due to the ripples observed along the edge of the Kepler Gap. The Kepler Gap is part of the rings of Saturn. If you look at my video, The Tour of the Universe, A Tour of the Solar System, I talked about Saturn. I talked about the Kepler Gap. 1 second here. I need a little drink here. Invisible drink. Daphnis, it's basically very, very small. It has about a mean radius of 2.4 miles. And it orbits only 85,000 miles from Saturn, completing one orbit in 14 hours. That's 2 Earth days, basically. 2 orbits per 1 Earth day. The gravitational pull of the tiny inner Saturnian moon, Daphnis, it protrudes the orbit of the particle of Saturn's A ring, and it also sculpting the edge of the Kepler Gap into waves. Material on the inner edge of the gap orbits faster than the moon. So when the waves there leave the moon in its orbit, it's surfing the waves. Yeah, the wings, surfing the ring. Material on the outer edge basically moves slower than the moon. So the waves there trail the moon. As you can see here, the waves Daphnis cause to cast shadows on Saturn during the equinox. When the sun is lit with the plane of the rings, you can see a small little shadow on the bottom. One of the next moons, the gravity waves, not gravitational waves in the ring, looks awesome. Yes, they do. That's why I love this picture. I could have got the other one, but I wanted this picture. Another one of the moons we're going to talk about is not from a movie, but it's actually a moon called Pandora. It was discovered in 1980 by the Voyager 1 science team. This is the potato-shaped moon of our system, Pandora. It's coated in a fine, dust-sized, icy material. I mean, even the craters on Pandora are coated in debris. Curious grooves and ridges also appear to cross the surface of the small moon. You know, Pandora is also interesting because it also tends to disrupt the F ring, while Prometheus helps to keep the primary ring in place. See, I told you I was going to talk about Prometheus. Let me repeat that. Pandora disrupts the F ring, while Prometheus keeps the primary ring in place. Pandora is about 25.3 miles in radius. It orbits about 88,000 miles away from Saturn near the F ring. And it takes about 15.1 hours to go around this whole entire planet of Saturn. I was going to say sun again. And oh my gosh, where's LDG? Because we are going to be talking about Prometheus. Yes, here's the moon Prometheus. This image was taken by NASA's Cassini spacecraft. As you can see, the detailed pockmarked surface of Prometheus. This is only 86 kilometers or 53 miles across. This picture was taken on December 6, 2015. Prometheus, it acts as a shepherding moon, constraining the extent of the inner edge of Saturn's F ring. Prometheus is extremely irregular and has visible craters, as you can see, some up to 12.4 miles in diameter itself. However, it is much less cratered than the nearby neighbors Pandora, Janus, and Epithemus. The density of Prometheus has been estimated to be very low, and it's probably a porous, icy body. This teardrop moon is basically about 26.8 miles a kilometer, I said. Oh, yeah. Hey, did you guys know what's up with the universe for January? What's going on right here? Well, if you just happen to look up in the night sky, you get a chance to see Mercury and the bright star Pollux. This planet and star, if you want to see Mercury, it appears in near the waxing moon, gibbous moon. Look for Mercury tonight and tomorrow at the night sky. I'm going to show you a little example how to look for it. As you can see in the diagram, Mercury is close to the edge. Well, if you take your fist out and you line your knuckles to the horizon itself, knuckles to the horizon, the top is where Mercury, of your hand is where Mercury will be. Basic math. Basic astronomy for you. Make sure your knuckle line up to the horizon. Put your hand like this, and your knuckles right here is where Mercury will be. Easy way to spot it in the western sky. And did you also know that tomorrow is the official full moon? Yes, we are talking about moons, and tomorrow is the next full moon. It's also known as the full wolf moon. The official appearing of the full moon will appear opposite of the sun at 2:16 p.m. or 19:16 GMT. The official full wolf moon. Hard enough, you will see the Zen Gardens, gift shop, LGD's gym layer. I should do a short little video on Prometheus. I should do one on Mountains of Elysium. That's a good idea. But I want to thank everybody here for joining me today on a little tour of Saturn's moons. And before we go, I just want to let you have a little video from NASA here to sum up everything that we talked about. So I want to thank everybody in tuning in for the day. If you didn't ring that bell, thank you for showing up anyway. If you're curious about science, thank you for showing up. So everybody, check out this little NASA video.